Okay, thank you, Daniela. Thank you, Philippe, and all the rest of the team for organizing this short lecture today. So I will speak about something which is not what we call a general introduction. So if you've never heard about what digital governance is and does, just have in mind we're trying to help governments, but also societies, use ICT tools in the best way they can to make their lives easier and better. So keeping that in mind, we have now an issue that started about 10 years ago. We are almost 10 years in this stream of research, which we call science-based for digital governance. So this started as an international project that was about 2015, I think, with several universities all over the world. And within this project that was called, you can find it in the web, was called Government 3.0. And it was an Erasmus project, by the way, international cooperation. And we came out by looking at this field, because myself, I'm almost 20 years in this field, but there are other people who are even more. And we're trying to bring some more of scientific ways, to bring some more of systematization, but not in the way we do research like literature research, but in the way we help governments. So we found out all these years that although we are a good, strong community and we have so many publications and so many prototypes and so many systems and tools, we still cannot pass this easy test. Now, that was devised, I call it the Yannis test, but we devised in one of our meetings. And because I always had this question, what is this digital government science-based and why do we need it? And, you know, through all these discussions, we finally said, you know, science first means method, and you must have a method to define that is well defined, and you apply it, and then this method evolves in a systematic way. But think about this test. Think about to take two independent, randomly selected digital governance experts, like practitioners of digital science. You can take, usually I use words like a PwC, PricewaterhouseCoopers consultant, that are many, assisting governments to go better, and another one from another company or from another domain. And think about it, you will expose them to the same problem. So let's enter into an administration somewhere in the world, assuming it's the administration of education, for example, the Ministry of Education. And you will show them the case there and what you want to do and the status you are. And the test says, if we have an applicable method and if this method is well established in our heads, then we should have like the same diagnosis for the situation. So both of these experts will say, this is a classification, a hierarchy of your problems, of what you need to solve. Maybe this is your status, and if you tell me where do you want to go, because always the patient has a status and he wants to go. It's different to train to become the champion in 100 meters, or just to be a nice 60-year-old guy being able to stroll around. So with this information, they should propose you the same set of actions, which is not the situation today. So this is what we're trying to do here all these years. Now, we studied other scientific bases, other scientific domains, mostly around computer science, so software engineering, algorithms and how we construct them, you know, areas of information science, but also more managerial scientific domains like business process engineering and the sort. And we found out after some research that what we call a science base has first to answer the main question, which is an existential question. Always you need to justify why you need that. So I try to provide you a small example. But then basically it boils down to having a way to understand, to have a common understanding about what we call the ontological issues of a scientific domain. So what is this domain? What are the areas of this domain. How you asked me before, what is this digital governance? And I said, yes, we're trying to make people's lives and governments' lives better. But there are several sub-areas into that. Maybe there are sectoral solutions, there are sectoral issues. So this is the structure. What is this scientific subdomain does? What are the areas? And then we find out that it's very important to position yourself concerning neighboring domains. You know, digital governance is not a domain by itself. It gets a lot from information systems. It gets a lot from management science. It gets a lot for political science also. Maybe also some people say we have ways to connect with legal issues, and we have to connect with the law science, if that is a science, and so on. And then we should have a research roadmap, meaning the way forward. We are somewhere here, but we have some research objectives as a community for the next 3 to 10 years, let's say. So now, for example, one of the biggest issues in our research is what we call AI-driven, AI-enabled, some of us call it algorithmic government. How AI is going to affect the way we work, from the parliament to the legislation house to the jury and so on, to the courts and so on. And then also to have a training curriculum, to have maybe more than one training programs and training courses and material on how to train someone in this domain. So this is what is the what part of things. If you have this, we praise. And we are working on developing those. I'll show you examples in my talk today. You are okay, you know what you're talking about. But then you have a more difficult thing that has to do with how you're going to do your task. As I said before, the main core, the science base, is to systematize practice. So to have consultants, to have practitioners of this domain that will come to the problem space and assess the situation, propose solutions, engage with solution makers, and deliver a final outcome in a way that is repeatable, in a way that is common to another opinion and not just different in every country, in every state, in every ministry, in every division of a ministry, in any department, in any sub-department, in any office. Because we see this multiplicity that is a little bit questioning to us. And then it's nice to have also things around how you're going to correctly apply. So it has to do with some code of ethics, and it has also to do with the big picture. So if we can go on and define some very generic rules that are understandable to anyone. To give you an example, for example, for the ones of you, do you have the chance to raise hands? Who knows the once only principle? Can you raise hands here? Can we raise hands in this meeting? There is one. The once only principle is a kind of generic rule. Once only saying the data of the citizen that you need to have as a state in order to provide services to him or her should be only required once and be stored only in one place. So, for example, in Germany, we had a very good practice for many years now that you have this way to declare your address in one space only. So there is a government service, if I remember well, that says when you change address, the government is going to handle that centrally. So you need to have this address only in one space, only in one information system. So these are the elements. This is 50% of our work was to define these elements and to say that we agree as a community or sub-community or a company, let's say, that these are the elements. This is an example. You see, structure of the domain. I try to do a small comparison about between digital governance and medical. So structure of the domain, we call it now we have the generations of government, which is a view of the structure. I will show you right after. Government 1, government 2, government 3.0. Okay, the others have pathology, surgery, they have their own subdomains. We have neighboring domains, we have training curricula, the similar way that a medical scientist also will have access to. We have research abroad, we're trying to solve big issues. We have some smaller issues and some holy grails, how to engage and how to make all the government, for example, information systems run on a blockchain, if you need that, if someone needs that. The problem space is very important, and we don't have that. I'll show you how we're going to tackle it and how we're tackling it, but we don't have a taxonomy of problems. So any problem for us is just a problem. If you, for example, are aware, who is aware of the DSM is a very well-structured manual of the mental disorder. It's an American system. It's like a big book that contains almost 300,000 smaller categories of problems that you might have in the mental space. But it's all classified. For example, every European country now is struggling to have a single diagnosing system for prescribing medication. In Greece, we did that the last 10 years. It was a very big struggle. But now we have one of the newest systems. So there is no doctor in Greece without this. If you don't have the information system to select what is the problem of your patient, you can go. You cannot write anymore a diagnosis on your own. You just select from an existing list. Imagine the level of complexity we're talking about when we talk about public sector organizations and their problems. So then assessment methods and tools. Yes, like you have the blood tests, the MRIs, we also have a lot of, I will show you assessment methods. Solution path, this is also very important. This has to do with the prescription. Like in medicine, we have the book of drastic substances. Says if you have this problem, and then also you have the protocol of application and so on. We want to make something similar for the digital government space. And finally, a selection of myriads of methods and tools. Now, let's see a little bit about the domain. The domain structure, yes. What is the composition of this domain? You know, there are many definitions up to now, and there are many lexicons. Lexicon, I mean, just a list of areas. There are quite several taxonomies, which is structured hierarchies, and we also have a few ontologies about what are the subjects of the digital governance domain. So our approach should be rather inclusive. We want to say, we found another one. No, we're looking from a distance, and we're going to propose a few things here and there. So it should be evolving also, because it's different today and tomorrow. We started in 2015, and now 10 years almost after, we found a lot of things that are said and new ones that came into practice. Oops. It should be simple. So I have a page for you. I can show you the structure in one page, but also it can be convincingly deep if needed. So we have different levels of analysis in this structure. And of course, there are always different views. We don't expect that we have this and this will be unquestionable and undebatable and needed. We need something in order to start. So this is the main part, is the area. So area is just a node that corresponds to a specific topic: interoperability, open data, all these terms that are very important for us in the domain. But of course, you can have upper levels and lower levels. For example, interoperability is now more or less agreed among us that it has 4 different subdomains: legal issues, organizational issues, semantic issues, and technical issues. And this is already a kind of established cluster in this big ontology I'm presenting you. And of course, for any one of those, of these links, of these areas, you must have a kind of definition what this is. You must have a specific link to Wikipedia, for example. There is a different task force we have trying to put definitions into Wikipedia, because we decided this is the best way to proceed in this way. But also we have other things. For example, streams. We call streams, which is an orthogonal structure to areas, something that says what type of area this is. So as streams, we chose what we have from information systems, the main areas of information system: process, regulation, data, people, infrastructure, and intelligence. Now, the fifth area. So if I go back here, interoperability is a very generic term, even within digital governance, but semantic interoperability has more to do with data, and organizational interoperability has more to do with process and regulation, because it mainly concerns series of activities, rules and regulations, and the sort. Now, then we have the first Cartesian orthogonal matrix. Imagine you have areas here. These are some of the areas of the taxonomy. And then you see you have a mapping across streams. You say digital identity. Oh, very important. It mainly is an infrastructure. It's a plastic thing, or it's a USB thing, or it's a software thing. But it has to do with identifying people, and it has to do also with a lot of regulation around it. So this is, excuse me, this is how it goes, and it can go on, because we're talking about a taxonomy which is about 100 areas here on the left. But I will show you a simplified version soon. So additional elements in this categorization, we have this idea of generation. So these are identifiers of big movements. See, if you talk about social media, for example, we already agree it's part of what we call today Web 2.0. If you talk about, I'm talking about Web 1.0, Web 2.0, and Web 3.0. If you talk about what is happening now with ChatGPT search and the sort, is more part of what we used to call for the last 20 years, Web 3.0. So similarly, we do here. We have these main areas, generation, big movements in digital government that more or less follow also the industry 1.0, industry 2.0, more or less. Okay, there are some resemblances and also some differences. And then we have this notion of collectives. Arbitrary, well coined though, and recognized identifiers as sets. For example, smart cities is not an area. It took us maybe years to understand. Smart city is a collector, is a collective, because it contains a lot of other smaller things inside that do not belong to it with the IM hierarchy, the ISA hierarchy that we use, as a class, subclass, as Dewey hierarchies do, and as Aristotle was doing, but is a collective, is a kind of another orthogonal thing. Say, for a smart city, you would need a lot of different areas and solutions. And then we have the verticals, which are vertical systems and sectors, of course, that are economy of society sectors. So if I give you an example, imagine service portals, government.xx systems. You have one in Germany, you have one in every state. You are based in Germany, I'm not mistaken, Daniela? Yeah, I'm saying Germany.
Yes, we're in Berlin. Yeah. We are located in Berlin.
Great,
correct.
Great. So you have the Berlin portal, you have also the Deutschland portal, and in the United States they have the Gov portal, and in UK, and every country has a central portal about everything. Soon this will go away because everything is going mobile. But still, this is an area of research and practice. It belongs to Government 1.0. It's an infrastructure mainly issue. Okay, and it also belongs to collectives like smart cities and service automation. And it's an horizontal system, but also can help a lot of specific sectors. So this is a view of, another view of this taxonomy along generations. So it took us also a few years of discussion, but in this community of communities, we have said that we have digital governance 1.0. This started maybe in the 50s, but 1950s, I mean, but mostly with the appearance of the internet. And this way it started, and it evolved from service automation to legal issues, to interoperability, to digital signatures, to authentication, to service portal, to some mobile applications, to cloud infrastructures. We are still somewhere, this generation stopped being very revolutionary somewhere at the end of the first decade, so somewhere at around 2010. Most research issues around those things have been solved. Not that it's solved and it's over. It still goes on, because in several parts of the world, they still don't have it, they still are looking for it, and so on. I have a very active phone, but I need to stop it. Okay. And then Digital Governance 2.0, this is started with the Obama administration in the States, and we call it open and collaborative governance. It has to do with involving citizens. So participation, voting, everything that can be done now with a digital way. Open governmental data, linked data for government purposes. E-collaboration, crowdsourcing, community awareness platform, and on and on. And now, for the last years, we are in the last part, in the last generation, the latest generation, which has to do with digital governments. We call it 3.0. Some people already started calling it 4.0, but this is not a big deal. That has to do with disruptive measures and decision making. Now, machines and digital means and systems are trying to go after what we call evidence-based decision making. So there is a lot of artificial intelligence, there is still a lot of blockchain, Internet of Things, policy modeling, societal simulation systems, opinion mining and sentiment analysis. We should be a little careful here. You remember your last week AI Act. So AI Act says, poses a few stops in doing that in massive by governments to analyze the sentiment of citizens. But still, it's a very vivid research domain for us. Yeah, so this is what we call the domain structure. And now what we're doing, we try more and more, and we do several rounds. We have this digital governance literature database, DGRL it's called, and this, you can find it in the internet. It's maintained by the University of Washington in the States, and it contains the papers, the abstracts, the titles, the authors, and a few more metadata of almost 20,000 research publications in the digital governance domain. Now, this is one of our core elements. We're using that because it's all our, and these publications are gathered from the community, meaning the conferences in the domain, the journals we publish in the domain, and also some very specific books and publications that are published by accredited publishers, and also contains the top notes of these publications. So 20,000 for the last 20 years. It's almost 1,000 publications per year. We also study the tracks of digital governance conferences, the work of esteemed digital government authors, to find out new areas, and we do lexical analysis. Now we're using LLMs in studying. So we have OpenAI systems dedicated to managing and studying all this work and extracting all the time, extracting new information on areas and the structure of the domain. Identification among the elements of the domain and their dependencies. Now, this is a big debate. You know, whenever you try to put some structure, always people disagree. one expert says, no, this one is the father and this is the son. The other says, no, this is an uncle, actually, belongs in the different subdomain. But it's a very productive work because it makes us realize what is that we're doing. And then community building to observe different points of views. We are building this community. And then we, as I said before, we develop various definitions, ontologies, and blah, blah for the areas. And also we have some tools for producing visualization of this. Now, so I gave you a view of what is that we call domain structure. Now, there is similar works and views on what is called neighboring domains, research roadmap, training curricula. But now I would go for the second, I don't have so much, for the second part, which is not as big as the first part of my talk, to go a little bit here and see what's happening in this, which is a more difficult space to conquer. So let's go to the difficult space and talk about the how. Now, the big picture, let's start with assessment tools. How we assess tools. I take again the medicine example, like the blood test. The blood test is showing you things about how many hemispheres, how much cholesterol, and we measure the blood this way. We do a laboratory analysis. After many, many, many years, we did it at hand. So it's all only the last 30 years that blood test is fully automated. In the past, it was first an art, first it was a miracle. Then it was a kind of art. Then it was a kind of practice for the doctors and only. Today is the task of someone who has a tool and puts your blood and waits for some minutes and then gets the results. And then you get 35 indicators in 7 categories. Okay, is there a historical element? Of course, because we need to have the sampling in different times, so to see progress. Do we know what is good or bad? Of course. There are ranges in the blood test and says, hemispheres red from this to this number. The similar way is how we work with any assessment. So the DESI index, digital index, this is the European Central Index of the European Commission, that now it goes to another index as well, that measures connectivity, human capital, use of services, measures digital governance progress in countries of Europe. It's done by trained staff, it's done manually still, it's not automatic, and it uses 48 indicators in 6 categories. There is a history element. We have DESI index of Greece and Germany today, 1 year ago. Every year we do this test. Do we know what is good or bad? Yes, but mainly in relation to others. So there is not a specific thing saying, if you are below 70% in this, you need a doctor, right? You need a consultant to make you better. We just compare country to country and we're trying to find some similarity. There are even other assessment tools. I've made a list somewhere, maybe later. It's like this. We have country, the EGDI of UN. You see, ESI is here, DESI is here. The digital, I don't remember E, but has to do with the status of information of digital systems in a country. And you see, we have several. Now, but the main picture is what? Let's think about it a little bit. The main idea, I would like to go here. Imagine we have these assessments. Any assessment is like we have a code of things. It has red hemispheres or level of interoperability or use of services. There is a label saying, how many people are entering every month in the digital government portal of Germany. I say, this is a nice number. Sometimes we measure it with integers, sometimes we have percentages, sometimes you have real numbers, sometimes you have lists saying ABC. Okay, and there is a range in the numbers, and then there is a value. So think about the value and think about all of these values. If you have a nice way to represent a little bit more mathematically, this is a kind of vector. It's a vector showing the decimetric measurement of Germany in a specific point in time. So what? So imagine.
Yannis, we only have 5 minutes left for the talk because otherwise we're going to run out of Q&A time. So if you could come to a conclusion, thank you.
I'm aware. Imagine then you have all these vectors. These are vectors of DESI, of IMAPs. This is another thing. Then what you have in a vector like that, what is a diagnosis? A diagnosis is a kind of pattern you find in this vector. So talking about the medicine, if you see high blood pressure, high cholesterol, okay, lower red and higher white, you call this guy hypertasic. And then you say, most probably this is a kind of general problem you have. So you see, we need to have this in mind, and situation looks like that. Usually we call it problems, but it's not, it's a situation. The German Ministry of Education is now in this situation based on the different metrics, and it wants to go into another situation, usually better. Okay, and this change we call a solution path. So we need to have that classified, like this is where you are, this is where you want to go, and these are the solution paths. So if you want to change your status from 93 to 98, then the consultant, but is the science base that should say, this involves the redesign of several key services. You need to subsidize broadband for SMEs, go mobile, see you again in 3 months. The other is the diagnosis. So this is where we're trying to go. I don't want to get any deeper in that because I need to go for the final slides and tell you where we stand. First, maybe I'll show you this. Where we stand has to do with, remember the definition I showed you before. I told you it took us 5 years to design this slide and agree these are the elements. And this is more or less the percentage I think we are right now. So we have a lot of ideas on how to say this is important. Domain structure, research roadmap, and training curricula, I would say 90%. Of course, in 3 years will be over again and we need to think again. But problem space, solution space, and solution method, the way to say, you need to do that. We need a lot of work. We have the idea, but we need a lot of work. Big picture, correct application, we're still behind. This is how it goes. We took this is from another scientific domain, this of software engineering. Usually it works like that. You see, we started the first wave to formalize the concept and to lay the foundational principles. Now, through additional work, what we're doing is we try to enhance. We try to build all this scenario I was telling you before, to justify, to clarify all these problem definitions, and to start populating with solutions. The principles are included in a book we published 2022, so it's already 2 years ago, with 50 contributors, authors, editors, reviewers, rapporteurs, 16 chapters on the various issues. This is kind of the manifesto. I think it's easy to find online. If you find problems in downloading, ask me, I will send you a copy. And we publish, we go on and publish and publish and publish, not publish in general, publish this, publish how we can go on and make this, and some more.